Hello everyone. So let's begin our discussion on this new topics, that is about Sulzer Artiflex engine, and this is the first electronic engine in its portfolio by the Sulzer. After RTA, this was the first engine introduced which is based on electronic platform where there are very new changes has come up as compared to a purely mechanical engine which is RTA engine. So as you can see in this overview picture that how this individual component looks like on a Artiflex engine. In Artiflex engine, just next to the flywheel on the drive end side, you will have a supply rail. This supply rail is basically going to produce the fuel supply in a common rail system which is pressurized at 1000 bar.
Are your promotions slow? Not getting the respect that you deserve on board ship? If you are a marine engineer who is looking for faster promotions and earning respect on ship, then don't worry, Merchant Navy Decoded has your back. Introducing excellence packages for every rank now. You want to learn about purifiers, compressors, electronics, automation, MEGI engines, Artiflex, ME engines. Don't worry, we are there. Learn anytime, online, offline, whether you are on land or on board ship. Engineers who invest on upgrading themselves, they lead. What are you waiting for? Go to the description box and you will find different ranks, different excellence packages. Start investing now. Jai Mata.
And here also we have another two small pumps which is also engine driven pump. These are going to produce servo rail power which is having pressure approximately 200 to 300 bar depending on the engine type. So these two units, which is the fuel supply unit and the servo rail units, these are mounted very close to the flywheel, or in some engine it is on a next platform depending on the arrangement how the drive is taken from the main crankshaft. So these two are again a new unit which is there on Artiflex. The fuel rail or the fuel supply unit is going to pressurize the fuel rail at 1000 bar. The servo supply unit which is going to supply the servo oil, which is the system oil from the main engine lube oil system, at 200 to 300 bar into a servo rail. Thereafter you will have the automations for the servo oil system in this place. This unit next to the cylinder head platform, below that, this is called rail unit, in which under the box or under the platform level you will have various rails like fuel rail, servo rail, cylinder lube oil rail. Even we are going to have system oil rails also online. So this is called the rail unit which is mounted below the cylinder head platform in a box shape manner. Here on the front of the frame of the engine, we are having all the electronic control modules mounted here, which is part of VEX 9520 control units, and here we all have the FCM module, FCM 20. Flex control module, 20 modules are mounted here, which is the brain or the backbone of this electronic control engine in Artiflex. So these are having various electronic control boxes which are communicating with various sensors, input and output, and thereafter it is getting connected to the control network through which the signal or the data flows to control room for controlling this engine. That is how the overview of various new components looks like here. Let's see something more on this, that how other components on this Artiflex engine looks like. So this one, this filter unit which is there for automatic servo oil system, here the oil quality should be much more enhanced as compared to the system oil. System oil filtering criteria is 15 to 20 micron, whereas the servo oil filtration quality should be at least 5 to 6 micron. So we have a separate filter units which is going to be placed in this location, which is going to filter the system oil, and then it is going to pass to this servo pump or the servo oil pump, which is again getting pressurized to 200 bar and going to servo rail. This is another view of the similar components in actual image from the engine room. As you can see that these supply units, which I had discussed earlier, that this supply unit is going to provide the fuel supply to the fuel rail at 1000 bar. These pumps we will discuss later on how this looks like, but here we need to understand that these are all engine driven pump and not electric motor driven pump. Here is the servo pump, which is again variable displacement pump, and again the drive is taken from the crankshaft only through gears. And these units, these are called the flex modules. Sorry, this is the rail units under the box, where we are having all the rails. It is all going from these units to this place, and this is running across, which is going to get connected to individual units. So this under box is called rail unit, whereas the flex control modules are mounted here on the outside on the engine frame itself, which is visible, and you can see all the flex module once you open the door. So these flex modules are the core or the backbone of this electronic control engine. So this is how the overview of these components looks like in actual image. So let's begin now, just to go back and see how the RT-Flex engine evolved from RTA engine. RTA engine, which was introduced in 1982, which was the first uniflow scavenging engine in the Wärtsilä or Sulzer portfolio. Thereafter, from here, the RT-Flex engine, which started its testing and introduction from 1996, and then 2001 the first RT-Flex engine came on board a container vessel, and from where the journey of RT-Flex engine became very popular, and this is very user friendly engine as well for the shipboard engines. So these are overview of the various generations of RT-Flex engine right from the beginning, where it is getting introduced into 1981. That was the development plan of the RT-Flex engine. Then they started working on jug top up fuel pump with some electronic control options, and thereafter we came with the common rail and electronic control engine, which is RT-Flex engine, and thereafter further development has happened, and currently they are 4th generation or 5th generation engines RT-Flex. The current RT-Flex engine is also known as X engine. That is how we know the RT-Flex engine in today's market, where it is competing with the MEC engine. So this is just a background of RT-Flex engine, how it evolved and where it is present now. And with this development, as you can see that as the engine development progressed right from RTA, which is introduced in 1982, the maximum cylinder pressure and the brake mean effective pressure is started going up. So what does it mean? It means that the engine power to weight ratio is becoming more and more superior, and that is how the electronic engine is more refined in this case, and they are having much superior power to weight ratio in that sense that you can compare that as compared to RTA, where our maximum peak pressure were close to 110 bar. Now we have reached to this stage where it is going very close to 160 bar, and same thing goes for the brake mean effective pressure, that is mean effective pressure were close to 14, and now we are going to be very close to 20. So by these introductions we are going to enhance the engine power to weight ratio as well as the efficiency of the engine.